We are very glad to welcome at Kherson State University at the 8th Annual International Conference on Information and Communication Technology in Education, Research and Industrial Application, Integration, Harmonization and Knowledge Transfer, Icteri 12. And first of all, I don't want to break our traditional, and before open our ceremony, I want to introduce, my opinion, the best master degree students, and I want to give the special device from me to these students, and I want to congratulate Viktor Yaroshenko with this device. Давайте поздравим его, да? Okay, let's continue our conference, and I would like to express my high respect and gratitude for the people who support and initiative made the conference possible. To our steering committee, unfortunately for me, but I don't know, maybe don't unfortunately for you, because the last year, during the beginning of May, when was a meeting between members of steering committee, we arranged about that in this conference, it will be the first conference when we use only one official language, English. That's why, because I promised, that's why I must talk only in English. Okay, that's why petitions my rusty English, but I hope my English is enough understandable for everybody. Okay, and I want to say the special thanks Vadim Yermolayev, Zaporozhye National University, Ukraine. Henrik Meyer, Alpen Adria University, rector of this university. Unfortunately, he must left us yesterday, but he very active participate the preparing of this conference. Mykola Nikitchenko, workshop chair, Taras Shevchenko National University of Kyiv, IT Talks chair, Mikhail Zavileyski, Data Art Russian Federation, and tutorials chair, Grigory Zhelkevich. It's our the big friends and the dean of faculty of Karazian State National, sorry. But I don't cannot understand what's the difference between state university and national university. Okay. But it's not my opinion, it's the opinion of rector of Kherson State University. I want to present our national, sorry. I want to present our special guest of this conference, the rector of Kherson National Technical University, Professor Yuri Bardachov. We are grateful to our program committee members who are present at today's conference. Michel Alabadi, Tirkit University, Iraq. Natalia Kushnir, Kherson State University, Ukraine. Thank you very much for the strong support our event. Andrew Bulat, Kherson State University, Ukraine. Please show yourself. Владимир Давидовский, Запорожье National University, Ukraine. Наталья Кеберле, Запорожье National University, Ukraine. Геннадий Кравцов, Kherson State University, Ukraine. Владислав Круглик, Kherson State University, Ukraine. Мишель Вов, Kherson State University, Ukraine. Владимир Песчаненко, Kherson State University, Ukraine. Владимир Сергеевич. Виталий Кобец, Kherson State University, Ukraine. And Professor Martin Strecker from Paul Sabater University. Besides, I would like to thank our foreign guests who visit our conference for the first time, but not the last time, I hope. Michelle Nagy and Michelle Kors from Finland. Stefan Kudak and Jan Baka from Slovakia. Viktor Tsilukin from Russian Federation. Special thanks for coming for the first, but I suppose not the last time, go to Tatiana Payenko, Stanislav Diardica, Елена Журан, Rustem Umerov, everybody is here, Rustem Umerov, Katerina Lavrisheva, Olga Slabospitskaya from Russian Federation. Skills. Custom software development company Data. So, Volkswagen Center Kherson and General Director Roman Romanov. Dmitry Shedorosov, Vadim Yermolayev and Ivan Devka. Thank you very much, because our budget is enough big and our efforts and our helps, for us, it's very important. And Yermolayev can explain what will be, but it's very short briefly, very briefly. It was initiated in 2001 by a joint European project Tempus Informational Infrastructure of Higher Education. It's really our history, our development. So different year, the conference presented the results of the international projects that were related different aspects of using information technology and in the institutions of higher education, training of specialists in IT sphere, development of educational software tools. This year's conference is the 8th one, and the scope was outlined by the following terms. You can see in this slide. This year, Icteri has attracted a substantial number of submissions, a total of 70 compromises. But it's really Vadim Yermolayev can more exactly explain what our results. It's really we have the very good results, and you can hear about these results later. Once again, I would like to express my appreciation that you did not leave our conference unnoticed. This forces us to improve our infrastructure, broaden academic and training resources, particularly information and analytics system of KSU. You know that everybody in my university uses this technology in administrative part, management, governance, and we can use this system for decision of academic issues. In addition, I'd like to present to you our new service, KSU Feedback. It's very important because I kindly ask everybody use this service for appreciate after finish of our conference, and come this service you can see in this slide, and use Feedback KSU KS UA and answer for 15 questions for evaluate of results our conference. Thank you very much, and I want give some words our special guest, Professor Bardachov, please.
Работает это что? Вот так лучше, да? Я не знаю, на каком языке Спиваковский говорил, да. Честно говоря. У меня подозрение, что он на английском. Но я тоже могу на английском, но тогда нужен переводчик, потому что это сленг. Очень хорошо звучит все это дело, если все еще понимали, было лучше. Надо переводчик, Александр. Ну а теперь серьезно. Ну, во-первых, слова благодарности. Национальный технический университет действительно рад сотрудничеству, искренне рад уже многолетнему. Мы рядом вместе, в грантах, в проектах, я об этом два слова скажу. А пока от всего коллектива университета, от профессорского преподавательского состава, огромное поздравление, огромное спасибо вам за то, что вы все это делаете много лет, делаете на высоком уровне, делаете очень профессионально. И состав гостей, которые сегодня здесь есть, об этом говорит. Спасибо огромное вам. Можно поаплодировать. Отдельное спасибо Александру Владимировичу. Вы понимаете, мне нет смысла там мстить ему или чего-то еще, мы не связаны административно, к счастью. Да. Просто огромное спасибо ему за все, что он делает в части международных связей. Александр, это искренне. Мы провели вместе два крупных гранта. Значит, инициатором был, естественно, государственный университет наш родной. Почему я вот господину Булату всегда кланяюсь, потому что он центральной фигурой был здесь. И действительно руководил ваш университет, хотя мы числились там координаторами от украинской стороны, но инициатива была всегда за вами. Но закончился грант, и, к сожалению, часто заканчивается работа по гранту. А вот технический университет, он эту работу продолжает. Я хочу об этом сказать несколько слов приветственных, так сказать. Сегодня мы нашли партнера, который финансово позволяет нам создать кластер университетский. Двоеточие. Что имеется в виду? Мы сегодня быстрым интернетом с помощью там оптоволокна прокладываем, объединяем все университеты в единый кластер. Эта работа сделана уже в аграрном, причем и общежитие, и корпуса, и так далее. Все это в единой системе. Работа сделана в аграрном университете, начата работа в университете, вернее, в Академии морской. Мы ждем, так сказать, долго вы тут работали с администрацией, выбирали ректора. Ждем, Олег Васильевич покойный, царство ему небесное, с большим уважением к нему, не успел подписать договор. То есть, чтобы государственный университет, я надеюсь, тоже станет частью этой программы. То есть мечта наша, то, что в гранте было заложено, Александр Ильич подтвердит, так сказать, сделать систему для студентов, для преподавателя, создать условия для мобильности, для того, чтобы IT-технологии сработали хотя бы внутри нашего родного города, среди базовых университетов, сработали по-настоящему, чтобы студент мог в любой момент, в общежитии он находится, в аудитории, студенты Национального университета послушать блестящие лекции Спиваковского, студенты вашего университета послушать наших преподавателей, аграрников, морских и так далее. В любом месте. То, что мы видели, скажем, во Франции, то, что мы видели в Австрии, то, что мы видели в Швеции у наших партнеров. Это действительно есть, хотя там тоже не 100% все это реализовано. Я думаю, что мы впервые в Украине, ну, вузов немного, мы 4 вуза основобазовых соединений. Понятно, для Киева это проблема, скажем, сделать. Но тем не менее, это реальная программа. Единый кластер будет сделать, и вы увидите, я думаю, через годик, самое позже, что все это заработает реально. По 2 университетам, ну, даже по 2,5, наверное, морской академии, это уже работает сегодня. Вот это то, к чему приводит работа совместная в грантах. Благодаря началу, благодаря европейским деньгам мы начали эту работу. И сегодня мы ее продолжаем, я думаю, через годик закончим. Поэтому и в этом деле большое спасибо Александру Владимировичу, искренне. Потому что он нас привлек к этой работе, я надеюсь, привлечет еще на миллиончик. Да, Саша? Как скажешь, хорошо. Евро, я имею. Вот такая работа. Это интересная информация, я думаю, для студентов, которые здесь сидят тоже, они же будут пользователями этой системы. И завершая свое коротенькое выступление, я хочу сказать еще раз, что без этих технологий, без того, чтобы они были активным участником процесса образовательного, процесса научного, движения вперед невозможно. Образование без науки просто невозможно, а самый быстрый доступ до информации научной – это сегодня IT-технологии. Поэтому успехов конференции, успехов руководителю такому серьезному. Александр, ну улыбнитесь, что. Спасибо. Спасибо вам всем.
We can continue our conference, and I give words the message from the PC chairs, Dr. Vladimir Malayev, Zaporozhye National University.
Good morning, everyone. Returning back to common language. Just 1 second, I need to plug in my USB stick. Yes, please. Please DND.
Okay.
Okay. Oops. One more thing to do. Okay. Ladies and gentlemen, what makes me proud and happy about this conference this year? As Alexander told us already, we have the 8th instance of Icteri this year. And just forward-lookingly, I would say that indeed we've managed, by some magic, to bring it very closely to the commonly accepted international standard. So, Icteri is a peer-reviewed conference for the 2nd year already, and this year our program committee comprised 49 internationally renowned experts from both academia and industry. The program committee was indeed very international, and you may see the distribution on this chart. We have people from Austria, from Egypt, from Finland, from Germany, from France, from Iraq, from Romania, from Russia, from Slovenia, from Sweden, from the UK, and of course some part of those people came from Ukraine. Remarkably, the interest to Icteri is growing and growing from year to year. This is the statistics of internet hits to the Icteri conference website. We've measured the hits starting from the 15th of November last year, when the website has been launched, and stopped the measurements on May the 15th, when we have already finished collecting the accepted papers and we're about publishing our proceedings. So we've got nearly 3,000 visits from different places all over the world. All over the world in this very case means 71 countries and more than 300 world cities. A more remarkable thing is that the traffic of coming from the search engines has been growing from the beginning till the end, and you may see a certain maximum at the very end. And finally, I just looked at the Google statistics today in the morning. We've got 102 hits to the program of Icteri conference, only yesterday. So that means that the conference becomes indeed popular at an international scale, and that makes me satisfied with our work. A more remarkable fact is that this year, though it was not especially requested, the proceedings, the volume of international proceedings of Icteri has been automatically indexed by a very well-known index, which is Database and Logic Programming Bibliography Server. I also would like to mention our nice cooperation with the UNISCON conference, which many of you visited last week in Yalta. With this conference, we had a small but very nice shared pool of best invited papers. People from Icteri came to Yalta and presented their papers by the invitation of their program chair, and we did similarly. Some people from UNISCON came to our conference and will present their research results in one of our sessions. Speaking about the scope, we'll do it quite shortly because Alexander mentioned that already. But two main tracks. The first is ICT in research, industrial deployment and knowledge transfer. And the second is methodological and didactical aspects of teaching ICT and using ICT in education. The thing I would like to stress here on this slide is that we are developing an ontology which is formally representing the scope of the conference as a set of UML diagrams using social web technologies and involving the submitters and the other people coming to this site to somewhat vote for different items in the scope of the conference, just to help us in improving the scope, in highlighting the items that are more popular in the community and perhaps dropping the items that are not that popular. All your visits are explicitly welcome to the web address which is given at the bottom of the slide. Speaking about the submissions, I would like to a little bit detailize what Alexander said as very good. Number of submissions to the main conference was, I would say, sufficient. We have collected 48 papers authored by 62 individuals that results in 1.255 authors per paper. Per tracks, we have 25 papers for the research track and 22 papers for research and education track. And per categories, we had 18 full or regular research papers, we had 20 short paper submissions, we had 9 discussion problem analysis papers, and we've got 1 industrial experience report. This year, Icteri is a little bit more structured than last year because we have introduced the main conference as the backbone, and we have also offered people to submit their own workshops. This year, we have accepted, thanks to our workshop chair, 3 workshops. One was Dynamics and Evolution in Intelligent Systems, another one was algebraic, logical and algorithmic methods of system model verification and specification. And finally, the third one is integration of information technologies in economic research. This is the numbers of submissions per workshop on the slide. The response to the topics of Icteri's scope was quite balanced and quite intensive, as you may see from this tag cloud. In fact, we asked all the authors of our submissions to tag their submissions both with their freely chosen keywords and with the fixed key terms taken from our Icteri wiki website. And this helped us to create this tag cloud showing the popularity of different topics within the scope. Remarkably, that some of the freely assigned keywords, especially the ones which are most popular keywords, coincide quite closely with the key terms we have defined in the Icteri scope ontology. I won't speak more about that because you will get more details about this work and the results and the measurements in one of the talks at the conference. The talk on our on-internet paper about acceptance. We accepted slightly less than 45% of submissions, which is, well, quite a good submission rate if compared to an international standard. You may compare it to the top shelf conferences, which are listed over there in the bottom of the slide. And the diagrams give you the acceptances both in absolute numbers and in percentage. For the workshops, the picture was very similar. We had 33% acceptance rate for day's workshop. We have 54% acceptance rate for SMSV workshop, and 25% acceptance rate for the Icteri workshop. This is the proceedings we have published on an international electronic resource which is well known in Europe. Our volume, published on May the 22nd, is number 848. I visited the resource yesterday. The latest volume is 890 something. So during this short time they have already published much more different conference and workshop proceedings. It means that the resource is very highly visible, very popular, and accepts only quality publications. Another good proof for the quality is that this resource has been used by DBLP Index to automatically index our conference proceedings. Not all of them are indexed by DBLP. Okay, I would like to show you our distinguished keynote and invited speakers. We'll have the keynote on formal foundations for RDF evolution and repair presented by Grigoris Antonio. It will happen today immediately after I finish boring you with all the figures and facts. And we have an invited talk by Martin Strecker tomorrow in the plenary session in the morning. He will tell us about abstraction and verification of the properties of a real-time Java. So now I have just a few final words about the rules of encounter, or, well, speaking other words, the conference game theory and practice. We have a very tight program, so we have to obey it. We have fixed time slots for a full paper, for a discussion paper, and for industrial paper presentations we have 25 minutes plus 5 minutes for answering questions. We have 15 plus 5 minutes for short paper presentations. And session chairs who are in the program, you can see their names, are advised to use strict or German if you want time management policy, because of a very tight program. And therefore 1 Icteri minute equals exactly 260 German seconds yet. There are some feedback instruments that will be used by the session chairs. The first is a yellow card. If you see a yellow card going up, you as a speaker get the information that you have only 2 minutes left to play the game. And finally, if you are unlucky and get a red card, that means that you have to stop right now. The speakers are advised to follow the rule, because if you take more time than planned, then the next session planned, scheduled for in this room, is under serious risk. So please do that as planned in the program. Finally, main conference language is exclusively English. Therefore, Alexander speaks English. Therefore, I speak English. Therefore, the invited speakers speak English. Therefore, each of the presenters at the conference speaks imperatively English. The reasons are evident. We have international attendance. Many of those people do not really understand Slavic languages. And we have international publication. And we all know well that people in computer science read and cite papers written in English, but not in other languages. So, but there is a relief. or some class, because the workshops and IT topics in the program take care of their languages themselves, and I don't bother. Therefore, I have the following very brief and mild suggestions for the presenters. Please speak English. Please don't feel uncomfortable if your English is not entirely Oxford style. Just make yourself understood. That will be sufficient, really. Please make your presentation slides in English. And we all wish you a very successful Icteri 2012, which of course would not be possible without our sponsors. I would list them or mention them individually because Alexander did that already. That concludes my talk, and if you have any questions, please go ahead. You have 30 seconds for it.
Thank you very much, Vadim. Maybe somebody has a question for our speaker. You can ask in Russian, but he answer in English, please. Don't worry.
I will pretend not understand in Russian.
Why
I understand only English.
Vadim, why English? Because in the previous year we had two official languages, Russian and English. But we had the big troubles in the evaluation of article.
I will have to work out unification.
That's why
if somebody asks something in a language different from English, you'll translate.
But in the last year we have 147 articles, as I remember. But now only 48.
We'll take all this discussion.
Oh.
Okay, if there are no questions, it is my great pleasure to open up the next slide. Our next bullet in our program is our keynote talk by a megastar in semantic and evolutionary technologies, who is Grigoris Antonio. Of course, this information is very exhaustive because for everybody it's fully enough to hear just the name Grigoris Antonio. But I'm a person who is risking all the time, therefore I would still remind you about some facts. Professor Grigoris Antonio is currently with the University of Huddersfield in the UK, but formerly he was affiliated with the Department of Computer Science at the University of Crete, and at the same time he headed the Laboratory of Information Systems at the Fourth Institute in Greece. I consulted DBLP index server today and found out that Grigoris has 211 DBLP index publications, and those listed in the slide are the top 3. The numbers in the brackets are the numbers of citations. Grigoris's Hirsch index, discovered by myself today in the morning using Google Scholar, is 38, which is very high. He is a European Coordinating Committee for Artificial Intelligence fellow for many years already, and which is most remarkable for me, is one of the founders of the European Ontology Dynamics Initiative. Please meet Grigoris Antonio.
Я ученый совет даже написан.
You see that there are the competent people and not so competent people.
Совет Юрия Николаевича помог сразу решить проблему.
Okay, so thank you for the introduction. Vadim, of course, overstated something, so I think my age index is 28, not 38. Okay.
I have some proofs of that.
Yeah. Okay. So it's thank you for the invitation. It's very nice to be here. This is a part of the world, to be perfectly honest, it's the first time that I visit, and so far I like it, including the people. And the title of my talk is Formal Foundations for RTF Evolution and Repair. However, I have to warn you already now that you will not see too much of formal foundations, because this title was originally for a workshop that didn't take place, and so I come to the conference. I will still talk about RTF evolution and repair, but I have kicked out some of the parts that were more formal. You see that my affiliation is University of Huddersfield, but I moved there something like 3.5 months ago. And previously I was in Greece, on Crete, and this work was done in collaboration with a number of colleagues there, including Vasilis Christopidis, Georgos Floris, Georgos Konstantinidis, and Yannis Tuksakis. Okay, so the structure of my talk is going to be, first I will motivate the problem, talking about linked data and ontologies. Then I will say something on ontology evolution, then on ontology repair, and I will conclude with one line of research that I think is quite interesting, if not exciting for me at least, that is happening just now. So let me start by saying that we are in a transition period again, and it's a quite important and exciting period, because you see an evolution not just of technology but also of the use of technology. So if you take the World Wide Web, you will see that it started by having people who published documents on the web. And then increasingly, linking became important. So they started to link it. So first you see that it is just documents on the web, and then it is the web of documents, right? So documents linking with one another, with each other. And then you have a period where more and more data start being added to the web, from databases and published on the web and made available. And now we are in the phase where out of this data on the web, you get a web of data, which means that data that is linking to one another, and you have possibilities of getting them all together. So to make it a little bit more understandable, let me just briefly explain the 5-star model for publishing web data, which is adapted by someone else, but what the original idea was from Tim Berners-Lee, who is the inventor of the World Wide Web. So you have, when you publish web data, you may get a star from 1 to 5. And so the more stars means the closer you get to what you would like to have. So 1 star is that you make information available on the web in any format. The only thing is under an open license. So you want to have open access. Okay? And so this is 1 star. 2nd star is that the information is available somehow as structured data. What do I mean by that? You may have data in Excel, and you publish this data as an Excel document and not as a screenshot that you take out of an Excel page. So because in one case there is some structure of the data and a machine can process it, whereas in the other case you just have a picture and it is very, very difficult to process this information. Moving one level further, you say, well, okay, Excel is fine, but Excel is a specific application. So if there is a format that is non-proprietary and I can publish the same information but in this other format, I move up the level of usability, of reusability, and the possibility of linking. And things start getting interesting when you get 4 stars, because then you have an identifier, which nowadays are called URIs, which are used to say that, okay, when I talk about something, I can point you to the originator of this information. Okay, so you publish some data, you get a unique identifier, and then other people say, okay, I want now to refer to this particular set of data. Okay? And the fifth one is data that has all the above and is linked to other data and, let's say, to provide context. So this brings us to the linked open data initiative, which is more and more gaining momentum. So let me briefly say what the basic ideas are. Linked open data allows me to publish information in a standard open format. So important is to talk about an open format, and important is also standardization. So very often we underestimate, I mean scientists, let's say, underestimate the power of standardization, because the moment that you standardize something, more and more people feel comfortable to adapt it, to reuse it, and so on. It may not be the perfect standard, but if sufficient people or companies or whatever use this standard, then it will create value in any case. Now, second principle is it provides ways of linking individual schemas and vocabularies. So linked open data is about linking, okay? So it provides mechanisms for linking, meaning, for example, importing information from other data collections. And it brings all this information to an environment open to be used by everyone, so it's non-proprietary. If you look at the history of linked open data, its foundation, it actually came out of the semantic web community, and I will come back to that, because if you have to look a little bit further down, you'll see that some of the semantic web technologies are used in the linked open data movement. This is a sort of map of where linked open data not is, but was half a year ago, almost. So in the middle you have Wikipedia, and then you have different vocabularies that are linking to one another, and the color is used to illustrate whether some parts are government information, there is media information, there is life sciences, and so on and so forth. Okay, so this is why the colors are used. Now, it is very impressive to see how this, over a couple of years, started as a small, let's say, the core around Wikipedia, small network, and it is growing, and growing. Okay. And now is something that I think is important, and not just for technology, but also, for example, for, let's say, young, perhaps even students, because there is a new opportunity around. There is a new opportunity for startups, there is a new opportunity of thinking of business models and trying to do something. You know, when something new is created, a new opportunity is created, you may be able to jump into it and do something quickly, as long as you have a very good idea, of course, right? That's why I'm at the university, for example, and some others make billions with social media, for example. So what is happening these days is that linked open data now is a resource that can be consumed. So the interesting thing is, you have a new resource, linked data, which on top of that is free. So all information published by governments, let's say, okay, is free. It's up to innovative people to come up and say, I will make use of this information in ways to provide new services that are useful to people. And then people are willing to pay, and therefore this is a business model. Okay? And you find indeed already a number of small and medium enterprises that are exploring different ways of utilizing this information, combining it, putting it together with other information that may be available, and producing new services. So, one of them is smart city. Okay? Another one is environment, mobility, real estate. So let me give you a couple of examples. Let's talk about real estate, because I moved recently and I had this problem. So I was even moving to the UK, which is very sophisticated already in linked data and in search engines for real estate and so on and so forth. So of course you can specify how many bedrooms you want to have, which area you would like to have, other characteristics, whether you want to have garden, how many bathrooms and whatever, that's fine. Yes? So you get a list of price, you know, you get a list of properties, you can click on each one of them, you can see photos. They even have a map where you see, which are the schools nearby. You think perfect? No, it's not perfect, because in the UK it's very important where are the good schools and that you move close to the good schools. How do you find them? Well, I have to go individually and look at the website of every school, read all the documentation about how it is evaluated and so on and so forth, or this is the catchment area, so am I in or out? Now what I would like to do would be to say I'm looking for a house with 3 bedrooms, 2 bathrooms, garden if possible, I want to be in a catchment area of a very good school, of at least this kind of ranking, and so on and so forth. Okay? And the funny thing is that all this information is actually available. Nobody provides it. So, you know, this is just an example of what we can do. And there are many other things that we do. I know of an application that said, how do I find a free parking space based on information that is available throughout the city and so on. Okay? So, anyway, okay, to be honest, some of these applications sound a little bit science fiction to me coming from Greece, and perhaps to you coming from Ukraine, but in some areas of the world, this is already happening. So I do not think that this is science fiction, this is reality. I should also point out an important European event called the European Data Forum that started this year for the first time, and it is about bringing together the stakeholders for building this data economy. Okay? And there are also other new funding schemes for funding small and medium enterprises. Okay, so this is as motivation. Now, if you dig beneath linked open data, you'll find RDF. So RDF is the basic language of the semantic web. And basically it's a modeling language, schema language, that allows you to do the following. It allows you to define classes like students, professor, building, course, and so on, if we're talking about university, and their instances. Vadim is a professor, and so on. It allows you to define properties, binary properties, such as this student is enrolled to this subject, this professor teaches this course, and so on and so forth. Okay? It has class and property hierarchy, so it allows you to say things like professors are university employees, and so on, and every undergraduate student is a student. And it has domain and range restrictions, so you can say that a course is taught only by a professor, okay, or a professor can only teach courses and not buildings, okay. So all of this is expressed in so-called statements, or sometimes called triples. And an ontology, I will say what it is. So basically, this information that I told you, the schema information that I told you, is a collection of such RDF statements. So ontology, I was even happy to hear the word ontology already in Vadim's talk. So it means that what I'm saying, that it is adopted more and more everywhere, basically in every scientific and societal activity. You start saying there are biological ontologies, there are medical ontologies, government tries to put that, there are legal ontologies, and so on and so forth. Why do we see these ontologies emerge? The reason is because they can be used for semantic interoperability. So, if I have a set of data, and someone else has, and someone else has, and they are somehow related, how are we going to build these bridges? And the idea is that if there is an agreed ontology, I can link my data to this ontology and all the others as well. And so someone then may go and say, I'm looking for this particular data. And you may get some answer from one data set, from another data set, from another data set. Okay? This is a way of bringing information together. Of course, things are more complicated, so I'm not going to detail. I'm just presenting the basic ideas here, because what happens if you have a subcommunity with one ontology, another subcommunity with another ontology, and then you bring bridges between the ontologies, and so on. Okay? However, having said that, ontologies, without ontologies, let me put it like this, you wouldn't have linked open data, and in a sense you wouldn't have any semantic web, and you wouldn't have a way of linking information with each other. Okay, so from now on, when I'm talking about ontologies like ontology evolution or ontology repair, I specifically refer to RDF ontologies. So this simple ontology language that has classes and their hierarchies, properties and their hierarchies, instances, domain and range restrictions. Okay. So ontology evolution. Why do ontologies change? Well, there are various reasons why you would do that. One is because the world changes. You are in a part of the world where you say that, suppose that you had a geographic ontology or an ontology of countries, and there was a country called USSR, okay? And then suddenly there was none. And instead, some new countries emerged, okay? The world has changed. Therefore, the ontology has to change as well. Second reason is our understanding of the world evolves. In biology, and not just that, but in biology, if you look at its history, you'll see that the organization of the different animals, for example, has changed over time, because our understanding, our scientific understanding of the classification of animals has changed. Well, if that changes, there's another reason why the modeling has to change. Now, when you're putting together, there is a trend to say that you have specific ontologies for specific subdisciplines, and then you want to unite them and, let's say, build the one standard biomedical ontology. Okay? Now, what happens in such situations is that there may be conflicts between different parts because they look at the same object under different aspects. Okay? So again, you may have to change something. And also, in scientific discourse, it often happens that there is a model, you write it down as an ontology, and then there is a new scientific observation that shows that your model is wrong. In physics, you had it in the evolution of physics is basically the evolution of having a model, finding a phenomenon, this phenomenon contradicts what the model predicts, therefore you have to adapt the model. So these are some of the ways why you may have an ontology that changes. Now, moving just a little bit into the formal foundation. So the way that we approached the problem was to map RDF statements to first order predicates. So for example, you see this C ISA AB means that A is a subclass of B. Okay? Or C instance means that X is of type A. So let's say X is of type student. Okay? Alright, so then an ontology is just a set of positive ground facts. Now, in RDF there is no negative information. So there is no way in RDF that you can say Vadim is not a student. Okay? So, how do you add? You say an update, I describe in this language, and to say a positive update is very easy. You know, I say that I have a specific fact, you know, Grigoris is a professor, I add it to my knowledge base. Okay, how do I delete? Well, I delete simply by adding negative information as update. So I say, Grigoris is not at 4. Okay, I put this information in. Okay, and this is an update operation. Now, what can happen is that when I want to make a change, I may violate some validity rule. So what I'm saying is the following. You're not allowed to write anything. You can write many things in RDF, but you cannot write everything. For example, if you have specified that a class is transitive. Okay? So what does it mean? It says that, if C is a subclass of B and B is a subclass of A, then C is a subclass of A. So if suddenly someone goes and says that I want to delete something, it may contradict this rule. Okay? Or there is another validity rule that says that class is A applies between classes. So if I say A is a subclass of B, it means A is a class and B is a class. So if I go and say B is not a class, I delete from my database something like that, you may have a problem. Okay? So validity rules, keep this in your mind, just that validity rules are a way of explaining or putting down some important properties that I want to have. Some of them are imposed by the RDF model, and some of them I may want to write down that in my application I want this to happen. So, okay, suppose that you have the knowledge on the left side. You have three classes, A, B, and C, and you have B is a subclass of C. And you decide to say, I want to add that C is a subclass of B. Can anyone tell me why the raw application of just adding this fact is not valid?
Do you know the answer yourself, Grigori?
I hope so.
Okay, please go ahead.
Okay, let's give some. Okay, the answer is that it contradicts the transitivity of is up that we just saw before. So the moment that I have C is a subclass of B and B is a subclass of A, I also have to have that C is a subclass of A. Now, so what could I do to overcome this problem that this validity rule is violated? There are two easy ways, two obvious ways. One is to say that, okay, I add that C is a subclass of B, but I delete that B is a subclass of A. Looks strange, of course, but yeah, it's one possibility. The other possibility is to add also the direct information that C is a subclass of A. Okay? So let's say that you have these two possibilities. How are you going to choose? Where your driving consideration is the impact of change. So what you want to, the driving idea of our work was try to make it, the change, as small as possible. Okay? Try to stick to the original knowledge as strongly as possible. So how do you measure that? I think I don't have too much time to spend on that. But basically, you define an ordering on the updates. So if you say that this ordering, this update is more costly than this update, or this update causes a bigger change than that change. Okay, so you end up with, let's say, three principles that we want to have. One is primacy of new information. So it means that when I say I want to add something, this something has to be added. I want to delete something, this something has to be deleted. There is just one special case where you cannot satisfy that. For example, if you say I want an update where I add that Grigoris is professor, and at the same time I say that Grigoris is not a professor. Now this is a kind of update that is self-defeating, and therefore you cannot enforce that, but everything else should be enforced. The second one is validity maintenance, meaning that when you start with a valid knowledge base and you apply an update, you got the result that is valid itself, which means it satisfies all the validity rules. And the third one is minimal change, which says that any other operation that I may apply has a distance that is greater from the original knowledge base than the update that I made. So, in the previous example, we saw that there are two ways of resolving this invalidity that may occur. And now on the second arrow, above the second arrow, you see that the operation of adding an ISA relationship is smaller than removing an ISA relation. So we say that I prefer to add that C is a subclass of A over to remove that B is a subclass of A. Okay? Therefore, I choose the second one. Now you may say, okay, and how do you have this preference relation? Well, we run experiments and basically we develop the feeling of what is preferable over another. Having said that, I think it's quite important to say that it is a parameter of the system, and therefore we can play around. So you may have an application and you say that for my application this preference relation looks better than the other. Okay, so the evolution algorithm then, okay, let's say that there is a general evolution algorithm that tries to implement this kind of reasoning, okay? And let me move to ontology repair. Now, validity is a quality indicator, okay? So let's say that I want to have an ontology that is not valid. I want to improve its quality, and therefore I have to find ways of reaching a valid outcome. There are two distinct steps. One is diagnosis, so find the validity rules that are violated, and the other one is repair. What changes do I have to make so that I end up with a valid ontology? Okay, the problem is quite similar to what we had before. Okay, so here are some more examples of validity rules. For example, we can say that properties must have a unique domain. Then you write that, okay, for every property P, there must be a domain A. And if we have that property P has domain A and domain B, then A and B must be the same. Okay? And another one is the correct classification in property instances. So you say that if P of x, y, and P, the domain of P is A, then X belongs to A. Okay? Now, we have the same situation where we have to define preferences so that we find the preferred solutions to the problem, so the preferred repaired ontology. And if you look at it from the perspective of, let's say, an ontology engineer, there are two ways of looking at it. One is preference on ontologies. So you have an original ontology, O0, and you have three possible outcomes, O1, O2, and O3. So, let's say that for some reason you may be able to score them and say that which is the highest score, it's O3. So this is the preferred outcome. Second way of looking at this problem is to look at the operations, the change operations, okay? And say that we have the preference of the change operations. This is what we had in evolution, by the way. And then you would say that, okay, the third one there is the preferred change, and therefore again this is the outcome that we want to have. So, on one hand, we have preference on ontologies that are result-oriented. I'm interested in the result. And there are some popular options for having such kinds of preferences. For example, prefer the newest information, prefer the most trustable information, so coming from a source that is more trusted. Okay? On the other hand, preferences on the difference, on the change, are more impact oriented, okay? And so here you have popular options such as minimize the schema changes, or minimize the additions of information, or minimize the deletion of information, and so on and so forth. Okay? It's interesting though to see that if you have an original knowledge base and you have a potentially desired outcome, you can basically use one or the other and you can achieve it. So if you have a strategy in one view, you can translate it to a strategy in the other view and vice versa. Okay, so what do you do for one violated constraint? Okay, so you diagnose the invalidity, you determine the minimal ways of resolving it, and you determine in return the preferred resolution of the problem according to the preference relation. But what happens if you have many violated constraints? Now it gets really complicated because there may be interdependencies between the validity rules. So it may be the case that I fix one problem and this way I create another two problems. Now I have to fix them. And perhaps by fixing the third one, I get another one. And then I have to take care of that. And of course, I also would need to see whether I create some cycles. Okay? Of course, in the best case, it would be the case that by fixing one problem, some others are also fixed. But let's say you stick with the first problem. This is an issue, right? And this is an issue that you cannot really solve beforehand. Okay? So you have to do it somehow at runtime. So how do you do it? Well, we came up with two distinct approaches. One, I would say, is the globally preferred. For those who have been long enough in the business, let's say in AI, this would just be, or this would be some kind of breadth first search. So you say that I have a problem, I try to resolve it. Okay, there are two ways of doing that, but they create new problems. Okay, green means the green one says no violation. Blue means there is more to be done. Again, this is green, this is green. So now we're finished. And now we say we have four potential results. Which one do we prefer? And let's say we prefer these two. Fine. What's the other strategy? The other strategy is depth first search. Okay? So in a sense, it's a greedy approach where we say, okay, I have some violations. How do I resolve them? This way. Which is the preferred of the two? Is the left one. Okay? Forget about the right one. Which one is preferred? This one? I don't prefer this one. Here's the option. Okay? So, as you can imagine, the characteristics are as follows. The first one, the breadth first search, in a sense, is exhaustive, and of course it's less efficient. Because it is exhaustive, it is guaranteed to find optimal solutions, optimal repairs. The other one is quicker, much quicker. On the other hand, it is not guaranteed to give us the best, globally optimal repair. Okay, it finds one quickly, one that is perhaps good enough, but it is not the best. Okay, so you have to choose. So why would you choose? You would choose the local one if you think performance is important. The other one is if it is important that you find the really best solution. Now, this web is already there. Does it solve the problem correctly? It does. Does it solve the practical problem? So is it ready to be applied to the linked open data? The question is, does it scale? The situation is now that there are more than a billion triples, so a billion of RDF statements. And it's growing very fast, as I told you. So therefore, maybe we should be talking about tens of billions of triples. Can these approaches, the way that I present them, deal with this high volume of data? No. So we have a problem. How do we solve it? And this brings me to the last couple of slides, and this is one of my current research interests. And it's about the following. How do you attack this problem? The good thing is that some people before me and some colleagues thought about simpler problems, such as how do I do simple RDF reasoning? Did the implementations until a couple of years ago scale to billions of triples? No. How did they decide to attack it? Well, the interesting thing that comes now is that we have another important trend in IT, which is cloud computing. Okay, cloud computing means that you may have a lot of computing infrastructure that is somewhere there, and you may use it to solve your problem. And in addition, it is distributed, because it's not just one big supercomputer machine, one crane, right? One super machine, but it is many, many, many machines. So then you're talking about distributed computing, meaning that you have a problem, you must be able to split it and send these jobs around to your machines, collect the results, and do something about it. So, in the last couple of years, there has been significant work on so-called scalable RDF reasoning based on mass parallelization. So mass parallelization refers to, let's say, in this community at least, to utilizing MapReduce. Who has heard of MapReduce? Okay. So MapReduce is about, well, you take a problem, map means you find ways of splitting it, you know, if you have huge data of sending, you know, jobs around. Then you collect all this information and reduce this a transformation step out of which you get a result that hopefully is what you were looking for. Okay? So this was done. Mass parallelization. Okay? So this is the approach that was used for RDF reasoning. And this is the approach that we want to try to attack this problem. Now, we have not started yet, but we have solved a problem that is similar, or somewhat similar, which is about inconsistency tolerant reasoning. So you have rules that attack other rules and so on. So we're able to solve it in a scalable way using MapReduce. And if you think about it, these integrity constraints are also validity rules, and their interconnection is that you fix one rule, maybe another one is violated, and so on and so forth. So this resembles this kind of situation, and this is the next approach that we're going to take. Now, suppose that we will not succeed. We hope that we succeed, but it is possible that we don't succeed. We're in the same situation where this RDF reasoning people were a couple of years ago, 2, 3, 4 years ago, okay, when they started thinking. And when they started thinking, they came up with two potential solutions. One was mass parallelization, the other one was approximation. Meaning, if I have a huge problem and I can't solve it in a perfect way, okay, I will solve it in a good enough way that is scalable. For example, what would it mean? It might mean that we give up full validity. So we say that in most practical cases, in most relevant cases, the result that we get is valid. But in some strange occasions, it may not be the case. For those of you who remember Prolog, Prolog was not sound in a sense, but it didn't matter because, you know, everybody used it, okay? Or you may give up optimality, or you may find some measures of how close you get to optimality, how close you get to full validity, and provided that you can do it in a way that is quick, okay, and therefore scalable. So this is where we are. I think we have a good understanding of the problem. I think we have formalized it properly. We have some algorithms that work correctly, but we're not yet able to apply it to these billions of statements that are now around in the link of data. And we are now in the process of trying to resolve that, because ultimately we don't just want to publish papers, but we want to be able to say, you have your linked open data, quality and repair is important, evolution is important, we have a solution for these problems for the linked open data community. Okay, thank you for that.
Thank you very much.
Is anyone having questions?
You propose a form of framework for reasoning about ontologies. And there is also a description logic to also aims to reason about ontologies. Can you compare the approaches?
Okay, so as I said, RDF is the simple language of semantic web, which allows you to write simple ontologies. But actually, you would like to write much more and put in this in your knowledge models than what you can write in RDF. And that brought us, as we say, to this ontology web language OWL, which is based on description logics. Okay. Now, I will give you my personal view on this, right? I mean, so it's a debate that is going all the time. I personally am not a very big friend of description logics. And the reason is that I fear that they may never scale. At least it is clear that they are much harder to process than simpler structures. Okay? Are they making big progress in their inference engines? They are. They really are. So it's admittedly it may be the case that in 5 years' time I would say yes. Okay, these guys they are already very smart, but they are able really to solve it to my satisfaction. Okay. At this moment in time, I would say that they add one or more layers of complexity over what we're trying to solve at this moment with mass parallelization. Okay, so in a sense, it's getting very hard to do that. This is the assessment that I make at this moment. Also, if you look at the practical projects, in most cases, they say we use OWL. Fine. But if you say, okay, which part of OWL they actually use, usually it is perhaps RDF plus rules, which is now this OWL2RL, you know, so this is basically, or if you look at how do you implement it, they implement with rule technology on the background, okay? And so then I say, okay, then at least for me, I also think it is more honest to say, okay, for the time being, we'll stick with this rule technology over RDF. We try to make it as scalable as possible, and then you guys continue and try to do this description logic, and either we converge, or we say that there are two alternatives, or we say that we solve the problem of putting it all together, and that's fine. But I think it has some way to go.
Thank you. Thank you. All questions, please.
Yes, please. Yeah. Thank you for very interesting lecture. But what you can say about implementation of your theory?
Yeah. Oh, yeah. Okay. Okay. So we had implementations of evolution and repair, but as I said, they're not scalable. Right? That's why we want, as I said, we cannot process billions of triples. So it's not scalable. Right. Now, do we have implementations for the kind of inconsistency tolerant rule reasoning that I mentioned before? Yes. And that scales. So we have implemented and run it on a network of machines, and we can easily process billions of triples. Okay, so it's a question of, if you refer to this work that I published here, it is a logical model, it has a prototype implementation, the implementation is not good enough. And it's not good enough doesn't mean that if you put someone and they try a little bit harder, then we'll have a good enough implementation. It is clear that the problem is so hard, computationally hard, but you can only solve it, let's say, with mass parallelization. So our next step is to map it, to map reduce, or one of these extensions. and then to implement it using MapReduce and see whether this is good enough. Does it answer your question? Thank you.
Thank you. We have time for 2 more questions, please. Yes, you.
How conception data is linked?
How?
Conception data is linked.
Consider conceptual data.
Okay.
What conception?
Okay. Well, there are various ways in the RDF model to say that, in my model, I'll use this class which comes from this vocabulary and another class that comes from another vocabulary and has a unique identifier. And in this way, I'm talking about, well, if in what I do, I want to say if X is a friend of Y, I don't write my own definition of what does friend mean, but I take it out of FOF, which is friend of a friend, okay? And I use that vocabulary. If I want to talk about a country, I want to make a statement, let's say about Greece, in my vocabulary that I'm developing. I don't go and define a class Greece, and then perhaps put some information about Greece and so on and so forth. I go and say, I take Greece, the definition of Greece according to Wikipedia, okay? If I'm a human user, or of course DBpedia, which is the linked open data representation of Wikipedia. And so this way I create a link between what I'm saying and this DBpedia. So this is the kind of link that I create. And then I create my own vocabulary, and perhaps someone else will link something from what they are doing to my vocabulary, and so on and so forth. Okay, this is how this network emerges.
Yes, please.
What standard do you use?
The standard.
For describe data.
Yeah, the data is described in linked open data. Data is described.
Standard.
Linked open data, it's called, yes. And the underlying model is RDF.
Do you know standard? ISO 11.
ISO.
11404.
11404.
Pardon?
ISO 11404. No, he doesn't.
104. What do you say about standard? General data types.
Yes. So I think there are many standards for data formats and describing data, but here somehow we're talking about something a little bit different. So it's not about data formats themselves, than about using data in a way that can be linked to one another. So it's if you want, we can discuss offline what you mean or what the standard is, which admittedly I don't know, so it's not about that. But it's yeah, I think it's a different it's a different aim. Also, yeah, I mean they may have this similar there may be the similar aim of achieving interoperability, okay, but I think linked data is much more flexible and at a higher level of abstraction and allows many different communities to publish the data and bring them together. Okay, it's not so much about syntactic interoperability.
Perhaps the very last question, if somebody wants to. Yes, please.
May I ask you about the scores of the ontologies? As I've seen on the last of the slides, you had the big ontology and the family of the ontologies. There were 3 of them, and you put the score 1, score 2, score 3. Is there the way of counting the scores or something like that. I'm interested in the results you're getting, or data, the numbers, or something else.
Okay, yeah. So I think the score comes from this preference relation that we're talking about. Okay, and this preference relation, well, to a certain degree, you may have internal measures of saying that you know, to implement this kind of operation, I need more more effort than another one, or the disruption that is caused to an ontology if I delete a class is much higher than something else. Okay, so this is where it comes from. Or you may define yourself to say that this is an important, it may be user defined. This is a part of the ontology that I don't want to change. I consider it fundamental, and therefore, or at least if possible, which means that if I get a result where there is a change in that part, I consider it to be bad. So it's whereas if I have another possible outcome that leaves this part untouched, this is what I prefer, and therefore it gets a higher score. So this is the kind of so at least in evolution we've run some experiments about the cost of different change operations. If you want to, you can talk offline about that. Yeah. Okay.
Okay. Yes, please. That would be a very last question.
What map tools used for this process?
What tools? Okay, so our implementation, because it's a prototype implementation for evolution and repair, was like writing our own application based on a RDF store that we had already. Okay, but when we're talking about mass parallelization and map reduce, then we will, it will be customized software basically that will import this knowledge and send it around.
Okay. Let me offer you to thank Professor Grigoris Antonio very much indeed again. And I pass my yellow card to Professor.
For me, okay, thank you, but not red.
No.
Thank you very much. Okay, I have the last question, but it's a very important question. What do you think about lunchtime? It's a good idea, but I remind everybody that we shall continue our conference in the sessions from 2 p.m. That's why we invite you to continue our job in the 5th floor in this building. Okay, thank you very much, and see you later.
А вот было, Наташа, где-то
есть. Где вы будете обедать? Куда едете?
You get 950.
Зачем до сих пор отключили?
Не нужно?
Then I change my wording all the time when I find someone and say reasonable expense, and I can say you get in legal trouble if you make travel expenses.
Вадим, Наташа занимается питанием.
Наташа.